What if medicine didn't need to flood your whole body, but could travel straight to the exact cell that's sick and nowhere else? This is not science fiction anymore. This is the future of treatment at the microscopic level. When you swallow a pill or take an injection, the medicine spreads everywhere. It enters the bloodstream and touches millions of healthy cells before it reaches the sick ones. That's why powerful drugs like chemotherapy cause hair loss, nausea, weakness. The medicine is working, but it's hurting healthy tissue along the way. So scientists asked a simple question. What if we could send the drug only to the problem and leave the rest of the body untouched? The answer is something incredibly small, but unbelievably smart. Nanobots. Tiny machines built thousands of times smaller than a single human hair, designed to move through your body like microscopic surgeons. They don't just float around randomly. They are programmed or chemically engineered to hunt for a specific cell, a specific disease, or a specific location inside your body. Think of a nanobot like a Trojan horse. From the outside, it looks harmless, invisible to the immune system, but on the inside, it carries medicine, safely hidden until the right moment. Each nanobot is built with three main parts: the shell that protects it, the targeting system that guides it, and the payload chamber that stores the medicine. Once injected, the journey begins. The nanobot travels through your bloodstream, navigating past billions of red blood cells like a submarine traveling through a living ocean. Normally, anything unfamiliar in your blood would be attacked immediately by white blood cells. But nanobots are coated with a special biochemical surface that tells the immune system, "It's okay, I belong here." That allows them to pass through undetected, almost like wearing a biological invisibility cloak. How do they know where to go? Every diseased cell, whether it's infected or cancerous, displays unique molecules on its surface, almost like a fingerprint. Nanobots are programmed to search for that exact fingerprint. Once they find it, they duck onto the cell like a key fitting perfectly into a lock. And only after they connect to the right cell, the Trojan Horse finally opens. The nanobot releases its medicine directly into the damaged cell. Not the cells around it, not the nearby tissue, just the target. This means higher precision, minimal side effects, maximum result. Inside the cell, the medicine gets to work immediately. The damaged or diseased tissue begins to repair itself from the inside out. Instead of flooding the body with chemicals, the cure is delivered like a sniper shot, silent, clean, and perfectly accurate. Right now, nanobot medicine is already being tested for delivering cancer drugs, repairing nerves, and crossing the blood-brain barrier, something ordinary medicine can almost never do. Soon, nanobots could unclog arteries before a heart attack even begins, or intercept a virus before you ever feel sick. The doctors of tomorrow may not hold scalpels or stethoscopes. They may be smaller than a single human cell. The future of medicine is microscopic.